College Algebra 2, Lesson 1, all about straight lines and symmetry. The straight lines, some of it should be a review, and symmetry might be new, and here we go. This is supposed to be a review on straight lines. Now, the slope-intercept form of a straight line is y is equal to m times x plus b. M is the slope and b is the y-intercept. We have as an example y is equal to 2x minus 3. 2 is the slope. We're going to change it into a fraction. So 2 is equal to 2 over 1. The first number we put on our graph will be the y-intercept. So when x is 0, 2 times 0 is 0 minus 3. Y is equal to negative 3. But we don't have to go through the calculation. If it's in the form y is mx plus b, b is the y-intercept. So we put a dot on the y-axis at negative 3. Then we use the slope to find another dot and connect the two dots. Now the slope is 2 over 1. Relative to the dot at negative 3, we change y by 2 steps and x 1 step. So if I go up 2 steps and over 1 step, we see another red dot. But I could start with that dot and go up 2 steps and over 1, and I'd be back on the line. Do it again, and we see the top red dot. So how do I get the dot that's way down to the bottom? Well, 2 over 1 is the same as negative 2 over negative 1. So if you go down 2 steps, that's going down, and then you go negative 1 steps in the x direction, that's headed to the left, and that's the lower dot. In this example, we have y is equal to 1/3 times x plus 2. 2 is the y-intercept. We put a dot on the y-axis at 2. And the slope is 1 over 3, so we don't have to change it into a fraction. It is a fraction. Now, 1 is the change in y, and 3 is the change in x. So, from the dot at 2 on the y-axis, we go up 1 step, and it's a positive 3. We go to the right, and we put another dot. We repeat. We go up 1 and go over 3, put another dot. Now, we have 2 other dots to the left. We could change 1/3 to negative 1 over negative 3. A negative over a negative is a positive, so we get the same number, but it's in a different form. So if we go down 1, and then we go to the left, negative 3 steps, that's our middle dot on the lower part. And then if we do it again, we go down 1 and go over 3 steps, and we see the leftmost dot, and that's our straight line. In our third example, we have y is equal to negative 2/5 x plus 4. So our first move is to put a dot on the y-axis at 4. And then we go down 2 steps over to the right 4. We have our second dot. We'll do it again to the right. We go down 2 steps and over to the right 4. And that's our third dot. And then we'll change negative 2/5 to 2 over negative 5. So we go up 2 steps and then to the left 5 steps, and we see the left dot. Now, this line has a negative slope, and the slope, as you look at it from left to right, goes down. The previous example, the slope was 1/3. That's a positive fraction, and as you look at it from left to right, the line goes up. The distance between 2 points. Now, these are special examples. If we look at the 2 black dots, the height of the lower dot is at 2, and the height of the upper dot is at 6. And we could say the distance between the 2 points is 6 minus 2, which is 4. And you could say 2 minus 6, that's negative 4, but you got to take the absolute value of that, and you get 4. So it doesn't matter which way you start. It's like a minus b or b minus a. You just take the absolute value. Now that's vertical distance. We need no fancy formula for vertical distance. Now if we look at horizontal distance, it's the same story. We do not need a fancy formula to find the vertical or horizontal distance. So for the blue dots, we could say, well, the leftmost dot is at negative 5, and the rightmost dot is at 7, and the difference of 7 and negative 5 is 7 minus a minus 5, which is 12. Here we have the distance between 2 points, and these points are not on a vertical line or a horizontal line. We need a special formula. And at the top we have distance is equal to the square root of. Now, it's the difference of the x numbers squared plus the difference of the y numbers squared from the points. Okay, the dot to the left, that's -6, 3. How do we get there? We start at the origin, we go 6 spaces over to the left, that's -6, and then up 3, and we look at the point to the right, we go over 4 steps to the right, that's a +4, and we go up 7 steps, and that dot is at 4, 7. That's its location. Now, we plug this -6 and the 4 into the equation. So -6 minus 4 squared plus, then the y values, 3 minus 7 squared, and -10 squared is 100, and -4 squared is 16. So you're taking the square root of 116, which is 4 times 29, and the square root of 4 times 29 is the square root of 4 times the square root of 29, and that's how I have the simplified answer as 2 times the square root of 29. But the key to remember, it's the difference of the x squared plus the difference of the y squared when we're trying to find diagonal distance, not horizontal or vertical. Right triangles. Now, we have 3 dots. One's at the origin, 0, 0. Another dot is at 4, 0. Another dot is 0, 3. For a right triangle, if you have the 3 sides, A, B, and C, it is always true, with C being the longest side, that A squared plus B squared is equal to C squared. And if you have 3 numbers, A, B, and C, such that A squared plus B squared is C squared, then they do form a right triangle. So in our example, if you take 4, that's the length of side A, that's 0 to 4, and the length of side B is 0 to 3, that's 3, and if you take 4 squared plus 3 squared, that's 16 plus 9, that's 25, and the square root of 25 is 5, C squared is 25, so C is 5, and so that we call that the 3, 4, 5 right triangle. But to verify it with the distance formula, the x values are 0 and 4, so you have 0 minus 4 squared plus the y values, 3 and 0, 3 minus 0 squared, so we get -4 squared is 16 plus 3 squared is 9, the square root of 16 plus 9, the square root of 25 is 5. This example is to determine if the triangle in red is a right triangle. And we have the points A, B, and C. Now, A is 7, 2, and B is 3, 4. So we have distance AB, 7 minus 3, that's the x value squared, plus 2 minus 4 squared. So we have 16 plus 4, that's the square root of 20. Now we'll do the distance AC. The x values are 7 and 8, and the y values are 2 and 9. So we got 7 minus 8 squared plus 2 minus 9 squared. Now we have 1 squared 1 plus a -7 squared is 49, so that's the square root of 50. And then we're going to find the distance B to C. And the x values are 3 and 8, and the y values are 4 and 9. So we do 3 minus 8 squared plus 4 minus 9 squared. That's -5 squared. That's 25 plus another 25, and that's the square root of 50. Well, clearly it can't be a right triangle, but just to be on the safe side, the square root of 20 squared plus the square root of 50 squared does not equal the square root of 50 squared, because 20 plus 50 does not equal 50. So how is the square root of 20 squared 20? Well, that's a famous formula here. The square root of wiggle squared equals wiggle, something we have to remember. And it doesn't really matter whether wiggle is positive or negative, but in that case, they're all positive, but the square root of wiggle squared equals wiggle. So by comparing a squared plus b squared to see if it was c squared, that was a sufficient condition to say that the triangle is not a right triangle, because we do not have a squared plus b squared equals c squared. Here we have the midpoint of 2 points. That's the point in between the 2 points. Now, it's a very simple formula. We add the x's and divide by 2. It's like the average or the number in between. And we add the y's and divide by 2. We have 2 points. In the second quadrant, we have a black dot. Its coordinates are -4, that's x, and 3, that's y. And in the first quadrant, we have 6, 7. 6 is the x value, and 7 is the y value. So we plug them into the formula. So -4 plus 6 divided by 2, comma, the y component, 3 plus 7 divided by 2, that's 2 over 2, and 10 over 2, and that's 1, 5. And we see the red dot, and that is the midpoint of the 2 black points. Now, we're not going to use that directly right now, but we will use it when we come to circles. Here we have a symmetrical problem. We will talk about 3 symmetries right now. There is another symmetry, but we'll talk about that later. And we have one box shown. And we'd like to say, is it symmetric about the x-axis, symmetric about the y-axis, or symmetric about the origin? And in our picture, if we were to turn our picture from the y-axis all the way at the top to the bottom, and the bottom to the top, we would still see the box as it is if we had see-through paper. So when we talk about symmetry with respect to the x-axis, that's making things up, down, and down, up. If you see the same picture, it's symmetric about the x-axis. In this picture, we have 2 boxes. Now, it is not symmetric about the x-axis. If you were to flip either one of those boxes up to down and down to up, the problem is it wouldn't be symmetric because above the x-axis we have 3 levels, but on the bottom we only have 1, so you would not get the same picture. But if we flip it across the y-axis, and you can think of this as left to right and right to left, we would get the same picture because we see the box on both sides. And so this is symmetric about the y-axis. In this picture, we have 2 red boxes. Now, if you flip it up to down and down to up, you do not get the same picture. If you flip it right to left and left to right, you do not get the same picture. Now, the picture is only the shaded red boxes. There is a box that's slightly shaded with dots. Now, if we take the box on the right and flip it over the y-axis, we will get where the shaded box is, and then we flip it again across the x-axis, we would get the red box that's below. And if you take the red box below and you shift it over the x-axis, you get the shaded box, and then you flip it across y, you get the red box. So if you do 2 successive flips, x-axis, y-axis, or y-axis, x-axis, and you get the same picture, we say it's symmetric about the origin. Parallel lines. Now, the blue line has the equation y is equal to 1/3 times x plus 4. The slope is 1/3, the y-intercept is 4. The red line has slope 1/3, and the y-intercept is -5. The 2 lines are parallel. And the key is that they have the same slope. They slope the same way. So the slopes of each line is 1/3. Here we have a special case with parallel lines. Now we look at the blue line. That's a vertical line, and its equation is x is equal to -3. X is always -3. Y can be anything. We look at the red line. That's a vertical line, and x is equal to -6. Y can be anything. So these are the only equations for straight lines that do not fit the form y is equal to mx plus b, the slope-intercept form. And then one might question, why don't they have a slope? Well, a formula would be the difference of the y's divided by the difference of the x's. But see, when you take 6 minus 6 or -3 minus a -3, you're going to get 0 in the denominator, and we cannot divide by 0. Now, if the lines are not vertical, we can make the statement 2 lines are parallel if and only if the slopes are equal. That means 2 things. If the lines are parallel, the slopes are equal. And it also means if the slopes are equal, the lines are parallel. And that only applies to the two lines that are not vertical. For vertical lines, we simply say two vertical lines are parallel. Here we have perpendicular lines. Now we could define perpendicular lines as if you take the two lines and you span the angle, say from the red line to the blue line, that would be 90 degrees. And if you look at the x and y axis, those are perpendicular. So for these two lines, we've taken the blue line, that's 1/3 x plus 4. So the y-intercept is 4 and the slope is 1/3. And the red line, y is equal to negative 3x minus 5. The y-intercept is negative 5. And the slope is negative 3, or you can say negative 3 over 1. And we plot 2 points and we get the red line, the same with the blue line. And the key fact is that the two slopes, when you multiply them, 1/3 times negative 3 is equal to negative 1. So when you multiply two slopes and you get negative 1, the lines are perpendicular. Now, this is the case that we previously had on the perpendicular lines, and what we're interested in, what is the point of intersection exactly? Not by looking at the graph and estimating, but exactly. Now, the key point here is where the two lines intersect, the x's and the y's are the same. So we're going to set the two y's equal to one another. One y is 1/3 x plus 4, and the other one is minus 3x minus 5. So on the right, how do we solve this equation for x? We're going to get the x's on one side, the numbers on the other side. If we cross the equal sign, we change the sign. So we see 1/3 x plus 3x. We moved it over, changed the sign. And you take the plus 4, you move it to the other side, it's negative 4. So we have a third x plus 3x. That's 3 1/3 x is equal to negative 9. If you divide both sides by 3 1/3, x is minus 9 over 3 1/3. And to do this division, you must change everything to improper fractions. So negative 9 is negative 9 over 1. And 3 1/3, 3 times 3 is 9, plus 1 is 10 over 3. And to get this, you do outies over innies, the outer product. So negative 9 times 3 is negative 27 over the inner product. 1 times 10 is 10. And I put the negative out in front of it. And 27 over 10 is 2 7/10, but it's negative 2 7/10. That's x. Now, how do we find y? We plug it into one of the y's, and I'll use the negative 3x minus 5. So y is equal to negative 3 times, and I want to use the improper fraction form, minus 27 over 10 minus 5. Two negatives make a positive. So 3 times 27 is 81 over 10 minus 5. And now we're going to turn that to a mixed number. 10 goes into 81 8 times, and you got 1 left, so that's 8 1/10 minus the 5, which is 3 1/10. Here we have the exception case for perpendicular lines. We have a vertical line and a horizontal line. Now, the vertical line has the equation x equals 6. It has no slope. The horizontal line is y is equal to negative 2. We don't see an mx there, but what it is y is equal to 0x minus 2. Nobody put the 0x in there, so y is equal to negative 2. You can't say 0 times no slope is negative 1 because the vertical line has no slope. So this is the exception case. When you have a vertical line and a horizontal line, they're clearly perpendicular. But you can't say the slopes, when you multiply them together, you get negative 1. But for any other case where you don't have a vertical line, you can say two lines are perpendicular if and only if, when you multiply the slopes, you get negative 1. That means two statements. If the lines are perpendicular, then when you multiply the slopes, you get negative 1. And if you have two slopes, when you multiply them together, you get negative 1. Then you will have perpendicular lines.